Welcome back. This is the day the Lord's made. Let's rejoice and be glad in it. In this video, I want to just do a couple samples, walking through how to name things, just to get you more practice with organic naming. So again, big idea is every part of an organic name is going to have a prefix, or I should say it may or may not. It might have things attached to it. It'll have a root, which is how long the carbons, how many carbons you have in your biggest chain are. And suffix would be the family it belongs to. That'd be like an alcohol or a double or triple bond. So and in homework assignment, you're going to get a lot of stuff given in a condensed formula. And so your job is to like name the compound. And so what you're going to do is you're first going to find out, well, how big is the chain? To do this, you're going to count how many carbons you have. So we have 1 carbon. We have 2 carbons, 3 carbons, 4 carbons, 5 carbons, 6 carbons. So 6, the root of this is going to be hex. All right, so the root of my name is going to be hex because I have 6 carbons in my chain. Now we're going to identify things that are attached. Okay, so we can see that if it's not a hydrogen, we're going to make note of it because we're going to specify that it's not a hydrogen. So here we have 2 things here, Br and F. Those things there, those things are attached to it. Now those things are going to be prefixes because halogens are prefixes or things that we've attached or substitutes. They don't belong to a family. All right, now to determine whether it's alkane, alkene, or alkyne, we see if every carbon has 4 bonds. So this first carbon here has the 3 hydrogens attached to, plus this next carbon is attached to. So these 4 things come after it. It's attached to 4 things. This carbon here has the previous carbons attached to, and the next carbon, so it's guaranteed the carbon on the front and the back end, and it also has 2. So everything should have 2 things attached to it between the carbons. It's an alkane if every carbon in the middle has 2 things attached to it besides other carbons. So 2, 2, 2, and the last ones have 3 because they're terminal. So this one's gonna be an ane. So when we come to naming this thing here, we're gonna do it alphabetical order for the things that are attached. First, we're gonna put our prefixes on, and then we're gonna put the root, then we're gonna put the family. So when it comes to prefixes, we're gonna put them in alphabetical order. And also too, when we come to figure out what number we should go from, we wanna have the smallest numbers possible. So we're gonna go ahead and make this carbon on the left carbon number 1. Not this carbon, because going from left to right, this puts us at carbon 2. Going from right to left, it puts us at carbon 5. And so we're going to use a smaller number. So bromine comes before fluorine. So we're going to say the name of this is 2-bromo. We're saying that on the second carbon, we have a bromine attached. Also, on the second carbon, we have a fluorine, and that's fluoro. So here we put our prefixes attached. 2-bromo-2-fluoro. Now, we're going to go to the root. That's going to be hex. So just so you know, between the last prefix and the root of the name, you don't need a dash. So it just goes 2-fluoro hex. So this hex is going to be the root of the name. All right, it's the root of the carbon. How big is the carbon chain? And it's all single bonds. So it's hexane. So the name of this guy up here is 2-bromo-2-fluorohexane. Next one. Let's do it again. So first, we're going to find out how long our chain is. 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5, 6, 7. So this time we have 7 carbons long. So the root is going to be hept. What's attached to it? Again, we see that we have bromine and fluorine attached to it right there. Showing up again, we have a Br and an F. Now, is it a single, double, or triple bonded molecule? Do we have any of those things present? In this case here, we do actually have a double bond. Again, the ones on the end should have 3 things attached. The ones in the middle should have 2. So we have 2, we have 2, we have 2. Okay, so here we only have 1 hydrogen. Because we have 1 hydrogen, that means this carbon has to make an additional bond to another carbon. So this carbon here has a bond to this carbon, has a bond to this hydrogen. The other bonds hasn't spent will go to the next carbon. So that means this is a double bond here. So we're going to have a double bond present. This is going to belong to the ene family, all right, because it has a double bond present. Now, when it comes to naming it, first we're going to put the things we put on as prefixes. But we need to first figure out the number. So do we want to count from left to right or right to left? So when it comes to hierarchies, double bonds are more important than halogens. So we're going to make sure our double bond gets a lower number, which means we're going to make the double bond get a 2. So we're going to say that is going to be on the second carbon. That means that the bromine and fluorine are going to be 1, 2, 3, 4, 5. They're on the 5th carbon, both those guys. So it's going to be 5-bromo -5-fluoro. Our root is hept. And now we're going to specify where that where the bond is. It's on the second carbon, 2-ene. So again, this name here, what it's telling us is everything we want to know about the molecule. It says that on the 5th carbon, there's a bromine. On the 5th carbon, there's a fluorine. The chain length is 7 carbons long. And on the second carbon, we also have a double bond. So again, it's a lot to say, but the good news is everything means something. There's no exceptions. Okay, next thing. So let's go and name the next one. This one looks like the last one. I just copied and pasted, but the only difference is you'll see that I have changed so that instead of having 1 carbon there, or sorry, instead of having 1 hydrogen there, now we don't have any hydrogens at all. That means that this carbon here, in order to get 4 bonds, it's got 1 bond to this carbon, and then the rest of the bonds had to go to this carbon here, which means we're going to triple bond there. So again, our root is going to be hept. We still have the Br and the F showing up. They're on the 5th carbon again. And we're going to be an ine this time on the second carbon. So the only thing that changes between these two here is that instead of having an ENE, we're going to have a YNE. We're saying that there is a triple bond on the second carbon going to the 3rd. Okay, so then you can find a triple bond if you see a bunch of carbons in a row. You're like, okay, those carbons must be spending all their bonds to themselves rather than with other things around them. All right, so to identify double bonds, look to see if there's only one thing attached to a carbon. To find a triple bond, there should be nothing. You're a saturated or a typical alkane as long as you have 2 things. All right. All right. Sometimes you're going to see parentheses on there. If you see a parentheses, the parentheses are to denote that you have a branch. All right. Whenever you see a parentheses in the condensed formula, it's telling you that we have a branch coming off it. So when you count the root of the name, they don't count. Okay. So this guy here, we actually have just 4 carbons. And it's kind of hard to see, but this is a Cl. I underlined it. That's a chlorine. Okay. I tried to underline it on your homework assignments too, but keep an eye on, I try not to use so many chlorines very often either. So, but in any case, so we have 1 carbon, 2 carbons, 3 carbons, 4 carbons that are part of the main chain. So our root's going to be bute. All right. This carbon here, that's actually an attachment. All right. That's an attachment. That's branching off of the main chain. So that means that on the second carbon, we have a branch coming off it. So we're basically saying, like, as we go up the tree, there's a branch going off, another carbon chain going that way on that one. It also has a Cl attached to it as well. The big idea here is if you see parentheses, it's specifying that we got a branch. So what do we have attached? We have a Cl, a chlorine. We also have a methyl. Methyl meaning that inside this parentheses, it is 1 carbon. In the branch, it's 1 carbon long. So when it comes to naming this thing, oh, sorry, is it a single, double, or triple bond? We see that everything here this has 3, the end should have 3. This has 2. This counts as 1 thing. That CH3 counts as 1 thing being attached to it because it's the carbon comes off and then that carbon, what does it have attached to it? 3 hydrogens, all right? And there's a chlorine. So this is gonna be an ane. It's all single bonds. So our root was 4. What do we have attached? We have a methyl and a chlorine going alphabetical order. What carbon are they on? They're on the second carbon because it's better to name this from the 2 carbon rather than the 3 carbon. So we're not going to go 1, 2, 3. We're going to go left to right, 1, 2. So it's going to be 2-chloro-2-methyl. Okay, we add a YL because the YL is to specify that it's a branch. It's a 1 carbon branch. All right. Bute meaning that it's 4 carbons in the main chain. Ane because it's all single bonds. So on the next one, you'll see that I have a parentheses, then I have something else attached to it. So let's go ahead and do this next one here. So we have, first we count carbons in the main chain. We have 1, 2, 3, 4, 5, 6. So the root of this guy here is going to be hex. What do we have attached? We have an attachment right here. We have 2 things attached that are the same. This is 2 methyls. that are coming off it. Not an ethyl, because it's 2 of the CH3s. So when we name this thing here, we have 2 methyls being attached. On what carbon? On the second carbon. Is a single, double, or triple? Everybody has 2 in the middle, 3 on the ends. It's a name. So our name is going to be 2,2-dimethyl. We're specifying that on this second carbon, we have 2. This 2, saying we have 2 branches coming off that. Just no different than you say H2, where you have 2 hydrogens. We're saying we have 2 CH3s. Hexane. Now, let me real quick just put one more in here. We'll do the same thing here, but the only difference I want to do is I want to make this, instead of having it CH3, I'm going to have it be CH2H3. Actually, I got to put it on a different carbon because otherwise it would be a different chain would be the longest one. So let me just switch places. There we go. So we're making a small change in this here. So our root still 1, 2, 3, 4, 5, 6. We still have the same root. This time, instead of having a methyl, what do we have attached? Our attachments are actually 2 carbons long. So it's going to be 2 ethyls. So this is inside the parentheses, we have 2 carbon, which makes it an ethyl. If there's 3 carbons in the parentheses, it'd be a propyl. If there's 4, it'd be a butyl. So our name is the same as last time, except that I did change the position. I made it on the 3rd. The reason I put it on the 3rd is because if I put it on the second carbon, then the longest chain would actually have been this thing. So it'd have been, oh, sorry, this carbon would have been the primary chain right there. So, all right, another example for us. So we have a lot more going on this one here. We've got to watch out for, we have some OHs too. That's great. So we have a carbon, 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 carbon. How many did we count there? 1, 2, 3, 4, 5, 6. All right, our root is still hex. What do we have that are attached? We have a Br attached, bromine attached right there. We have an OH here. That's going to be a family. So we also have an OH. So they'll be put at different places. And let's go ahead and get rid of a hydrogen here. That way we can have a double bond. So we're going to have a double bond right there as well. So we're going to have an ene right here. Now to figure out which numbering we go, we need to make sure the alcohol gets the lowest number. So because the alcohol is found on the second carbon going from left to right, we're going to specify this left here is carbon 1, and this carbon here is carbon 6. So the bromine that's going to be on carbon 1, and the OH will be on carbon 2. Where's my triple bond, or sorry, my double bond? 1, 2, 3, starts on the 3rd carbon. So the ene is going to be on the 3rd carbon. So when we name this thing here, first new prefix is 2-bromo. And since we only have 1 prefix, we don't need to put another dash in there. We'll go right into the root, hex. Now we have 2 families. So we're going to put the double bond first, 2-bromo hex dash 3-ene. We're saying that on the 3rd carbon, right here, this carbon has a double bond. And then on the 2nd carbon, we have an alcohol, an OH. So 2-bromo hex dash 3-ene dash 2-ol. So again, hopefully that helps you with some naming stuff here. I'm going to go ahead and pause the screen real quick for a second. And I'm going to add a new thing for us to take a look at. Let me choose a different screen to look at. So here, this is just a little fancy little simulator that lets me take a look at some stuff and the names and stuff. For the most part, it does a pretty good job. So this is just giving a visual aid to what we've been looking at here. So if we were to name this guy right here, it is 1, 2, 3, 4 carbons long. When we come to naming this thing here, oh, and also we should mention that this right here between the 2nd and 3rd carbon, they don't have 4 bonds. This carbon here has 1, 2, 3, 4, but this carbon here only has 1, 2, 3. What does that mean? That means between these 2 carbons, we have a double bond. So when we name this thing here, we have a double bond and we have a fluorine. So we're going to have 2 fluorine. We're going to count from right to left because we want the fluorine to be a smaller number because it wouldn't matter for the double bond. This could be 2 or 2. It'd be the same either direction. So 2-fluoro dash but dash 2-ene. All right. If we were to add a chlorine to this thing here, it would get rid of that double bond. So let's go and put a chlorine right here and add a hydrogen. See if it names it right. Look at that. Nice job. Now, I did use a dash there. We don't use a dash in my class. Okay, so we don't put an extra dash right there. But so counting from right to left, 2-chloro, 2-fluorobutane. Again, even though from left to right, it looks like 1, 2, 3, we're not going to count it left to right because, again, the molecule could just rotate around. So we're counting from right to left, 1, 2, 3, 4. We're saying on the second carbon, there's a chlorine, and on the second carbon, there's a fluorine. And but means 4 carbons and all single bonds. So good job, simulator. You did it right. So this guy here, ethane. Why is it ethane? 2 carbons, all single bonds. So if you cut some of these hydrogens off, what do we have now? Now we got a double bond. Now again, it's using its common name. This is ethene. We could cut some more off here. This is ethyne, common name, acetylene. Put another carbon back on here. Right here, this should be propane. It has N-propane. Sometimes, like you talk about, if it's not branched at all, it's just N-propane, but we're just gonna call this propane. Now let's put a fluorine on back on here. 1-fluoro. Why is this 1-fluoro? Because it's on the first carbon. If we switch places with the hydrogen, then it becomes 2-fluoro. If we keep going over, it's back to 1-fluoro, because again, it doesn't matter which way it comes from, we could just rotate it around. It's the same thing. The fluorine here, fluorine there is the exact same thing. All right. Here's another example. Now, again, I wouldn't use this E right here, but again, it's a good example saying, hey, we got 1, 2, 3, 4 carbons. And on the first and the third, we have an alcohol. Let's go and take this guy off. Name this guy here. Again, we would want to make sure that the OH gets the smallest number, 1, 2, 3, 4. So we're going to count this as the second carbon. But, because we have 4 carbons, butan dash 2 dash all. So that's how this would be named. All right. Oh, can't put anything else on here. Oh, we can. Put another. Oh, let's go back to the OH here. Oh, yeah. There we go. Look at that. Now we got 203. Oh, this is good. All right. Wow, we got 3 families here we're part of, or we should say 3 attachments that are families. On the first and the fourth, we have an OH. Diol. 1, 4 dash diol means, hey, we have 2 OHs. But dash 2 dash ene, we're saying that between these 2 carbons, we got a double bond. So again, I love organic chemistry because everything means something. Every part of the name means something. All right, that summarizes how to name things. God's peace.